Hello, chemistry class. So I'm going to be doing the chemistry of beauty products. As you can see, there's a really pretty person right here. So first of all, I'll be doing the chemistry of shampoo. And if you just wanted to get the job done and you just wanted your hair to be clean, all you would need would be a surfactant and water. And it would basically just look like soapy water and it would get the job done. But we live in a consumerism world, and so we want to be marketed to. You want to have the pretty person on the ad and the pink shampoo and the nice smelling shampoo. So that's why the chemistry of shampoo is so complex. A surfactant, which is also known as a surface active agent, is a chemical that has a polar hydrophilic head and a hydrophobic tail. And basically what it does is it reduces the surface tension between oil and water, and it's used to separate oil from the hair follicle and wash away the sebum. So basically how shampoo works to clean your hair is there's a chemical called a surfactant that has a polar hydrophilic head and a hydrophobic tail, and it's used to separate oil from water. And see, as you can see, there's the nonpolar tail and the polar head. So the polar head attracts the water, and then the nonpolar tail attracts the oil, which is also known as sebum, and it naturally occurs on your head. And it can also occur because of if you're using beauty products in your hair, like hairspray or something. So basically what shampoo does with the help of surfactants is it strips the sebum from your hair so that your hair will be clean. So most shampoos that you'll buy have many different types of surfactants with different roles, but they work together to improve the overall formula of the shampoo. Anionic surfactants are one type of surfactant, and an example of that is sodium lauryl ether sulfate, and their main role is to clean the hair and also to make the shampoo foamy. Cationic surfactants are another type of surfactant, and some examples are oleoconium chloride and disteryl chloride. Sorry if I butchered those names, but their main objective is they have conditioning properties, as you can see by the model on the right. If you use shampoo with cationic surfactants, your hair will look exactly like this. Amphoteric surfactants are another type of surfactant, and so amphoteric means that it can either be an acid or a base. It has both types of properties. And so some examples of that are cocamidopropyl betaine or cocamidopropyl hydroxysultane. Sorry if I butchered those names. And the main objective of amphoteric surfactants is foam stabilization, and also it builds viscosity, which means it makes the shampoo thicker. Another type of surfactant is non-ionic. The main function of these is to build foam stabilization and viscosity, just like it was for amphoterics. And so a main example is polyethylene glycol. So some other components in shampoos are conditioners, obviously. And the conditioners are used to help with static control. And so one main conditioner that is used is quaternized cellulosic polymers. Manufacturers will also use sunscreen as a type of conditioner as well. To maintain the moisture from the conditioners, they also put in preservatives and antioxidants just to lock in that moisture and make it so that the shampoo has longer shelf time. Another important component about shampoo is pH. So the pH really needs to be between 5.5 and 6.5 to be an effective shampoo. So basically, as I mentioned before, you want to strip the hair of sebum, which is that oil, to make the hair clean. But you have to do it very carefully because the hair can get aggravated, and basically, as you can see, you see those little hairs on the hair follicle. They're actually scales, and the scales need to be calmed down after the sebum is stripped because it's like a stressful process for the hair, whatever. And so the scales need to be calmed, and that acidic environment makes it so that they're calm. And if they aren't calm and they freak out, your hair is going to look all frizzy like this, and it's going to make your hair rough and dull, which is why the pH is so important. So next I'm going to do the chemistry of hair coloring. So to understand how the chemistry of hair dyeing works, first you have to understand the hair follicle. So basically, as you can see, the outermost layer is the cuticle, and it's scaly because of the protein granules. So the dye has to penetrate through this cuticle to change the color of the hair. So the proteins on the outer cuticle of the hair are called melanin proteins. And the melanin type determines what color hair you're going to have. So eumelanin is the darker shades like black and brown, demonstrated through this half of this woman's hair. And then pheomelanin are the lighter shades, and that includes red and blonde hair. And surprisingly, white and gray hair is actually just the absence of these melanin proteins. So when you get older, your body stops producing them. Semi-permanent hair dyes are typically targeted to older men, so men with gray hair or whatever. The main component of these hair dyes is lead acetate, and so the lead cation reacts with the sulfur atoms that are a component of the protein on the hair cuticle. Lead sulfur is formed, which is a darker color and causes the hair to turn back to black or brown. Permanent coloring is a little more complex, and so basically in the package there's going to be the 6% hydrogen peroxide solution and then a 1% ammonia solution with intermediates, which are called couplers. And then this is, like the bottle you would mix it in to actually put it on your hair. Some of these intermediates are paradiamine benzenes and aminohydroxybenzenes. And basically what they do is they develop the color when they're oxidized that changes the color of your hair. And so the different oxidations will provide different hair colors depending on what you want. So if you want a darker shade, use a higher concentration intermediate. And as you can see, this girl's really enthusiastic about her dark hair. If you want a blonde shade of hair, resorcinol is added. And as you can see, she's just really excited about that. And if you want a red shade, 4-amino-2-hydroxytoluene is added. So my final category is the chemistry of lipstick. So there are 4 main components in any lipstick that you use: wax, oil, pigments, and emollients. So the first component, which is actually a large percentage of the lipstick, is waxes, and basically it gives the lipstick shape and easy application. And the waxes are made out of esters of straight-chain monohydric alcohols, and they have long carbon chains within them that's between C24 and C36, depending. So there's beeswax, which is from the honeycomb, which is right here. And then there's carnauba wax, I think that's how it's pronounced. And that comes from the Brazilian wax palm tree, which is right here. So next there's the oils, and there's a variety of different oils that are used, but some of the main ones are olive, mineral, and castor oil. The purpose of the oil is it forms a tough, shiny film after it dries, like on your lip. And just a fun fact, castor oil is used in 50% of the lipstick manufactured in the United States, which I thought was interesting. And the next component is the emollients, and that's basically the moisturizers. And so there's a variety of different emollients that are used, but some are vitamin E, aloe vera, and sunscreen. Basically, it just moisturizes the lips and just makes your lips soft and protects them from the elements. And then the last component is the pigments. So bromo acid is the most common pigment used to create red lips, as you can see from this model right here. And then basically titanium dioxide mixed with the bromo acid creates the pink pigment, as you can see right here with my girl Rihanna. So obviously there's different types of lusters that you can get from lipstick. So one of them is frosted. you know, like a shiny lipstick, as you can see right here, and that is created through bismuth oxychloride. Another type of lipstick is matte, and just for the boys, it's basically, it just doesn't have any luster. It's as you can see on this girl's lips. Please ignore her eyelashes. I don't want to talk about it. But basically, it has more wax and less emollients just to create that matte finish. The manufacturing of lipstick, basically what they do is they finely ground the mixture of the components, and then they heat the heck out of it, as Dr. B would say, and then they cool it down in the mold of what the lipstick is going to be in. And then finally, they just put it under a flame for about half a second, really, really quick, just to fix any imperfections and just make it look, you know, finished and shiny so that it's presentable. So yeah, that's my presentation. I hope you guys liked it, and I'm going to insert some clapping now so that even if you guys don't clap, I'll be clapped for.